Shall we start?
Yes, so please give a warm welcome to our second speaker, Damian Rusinek, about smart contract security.
My name is Damian Rusinek, as it was said. I'm a security consultant and researcher at Securing and also assistant professor at Polska University. And I mainly focus on the blockchain. I'm going to show you some similarities and differences between web applications and smart contracts, decentralized applications, after all. And if you are interested in more technical stuff about the security of themselves, okay, and who's from business, like product owners? Cool. Okay, so I'll try to give all three groups of you today, and I hope you will like it. So let's start with this. Well, in general, decentralized applications are like web applications, we all know, but with decentralized storage and governance. Because they are usually on some kind of blockchain or other DLT, distributed ledger technology. And as an example, we can take Facebook or Reddit. It's an example of application. If we go to Meet, it's this version of Reddit, right? So why are they so important? Well, there are billions of dollars on the market, so that's the first reason I would say. Also, it's a great chance for newcomers, for fintechs, because it's very easy to do some decentralized finance. Also, there are very nice projects that proved that its value, the value of decentralized applications, and also there are big players behind, so it must go forward, I would say. So what's so special? Well, the thing that is special about decentralized applications is the same that comes from the DLT, right? It's trustlessness. And you actually have the so-called database of the decentralized applications, and no one can actually turn it off permanently. Even if you turn off some nodes of the network, it still works in general, right? So let's go to the differences in the architecture. The web application architecture is quite common, right? We have two centralized servers. One, sometimes it's even one server for front end and for back end. In case of decentralized applications, we store everything on blockchain. We can store backend in the form of smart contracts, and we can store front end, usually some kind of JavaScript application. We can still store it on IPFS, Ethereum Swarm, or any other storage blockchains. However, more common architecture is this one, where the backend smart contracts are, of course, on the blockchain because they are the core of the application, but the front-end application in the form of static JavaScript files is kept on a centralized web server. And that's okay, because usually that's a code that you can read and verify. So it's nothing hidden, nothing on the backend server that we cannot actually touch or see. So the main question for me as a security consultant is, are those secure? Well, from one side, they are, because blockchain is indestructible, right? So nobody can turn it off. And we can all transactions, so it's inconsistent. And also, as it is public, and I'm talking about public blockchains, it's publicly verifiable. So anyone can actually see what's going on, and if something's wrong, you can just say that something's wrong and it's cancelled. But still, from time to time, we hear about big attacks where millions of dollars, of course, in cryptocurrency are stolen or frozen, whatever it means. For now, and also there are quite nice reports on security vulnerabilities in the smart contracts or any other applications based on blockchains. So it's as usual, the expectations that blockchain will secure everything versus the reality that it's not that nice. So it's not a revolution, but you know, we need security. And I was asking who is from business and who is developer, because the needs are quite different for you. The technical security needs are like, they also want to produce secure code, build secure applications, right? On the other hand, business doesn't care about the technical stuff that much. They just want to have secure applications, or they want to check whether the application is secure. So they want to know the status of the security in their system. And there is a lot of security projects and standards that allow us to answer these questions for developers and for business. And the first question to you, in case of web applications, do you know any project that you would go for if you wanted to know the most common security vulnerabilities? Exactly, OWASP top 10, right? That's the most common project, I would say. Also, if you wanted to go much deeper and perform an end-to-end security audit of your application, of your web application, it's called SDS, Application Security Verification Standard, and it's also by OWASP. These are the standards that are very popular in web applications world. So let's now switch to the decentralized applications world. Do you know what's the project that is similar, that is equivalent of the OWASP top 10? Actually, there is DASP top 10, Decentralized Application Security Project. It's like the clone for smart contracts for decentralized applications. And when we tried to find some kind of security checklist to perform end-to-end audit or security audit of the decentralized applications or smart contracts, we actually couldn't find any. So me and my friend Paweł created one, and that's the one that I would like to show you today. It's called SCSVS, Smart Contract Security Verification Standard, and our objective was quite easy to define. We wanted to create something that will be useful for developers, for security reviewers, and also for business. And we wanted to meet the technical needs to mitigate known vulnerabilities, and also to develop high-quality code. And on the other hand, we wanted to give a business a tool to check what's the security coverage in their project, in their system. So we've the format of our SCSVS is very similar to ASVS. So we have created 13 different categories to spread all these security requirements that you should check. And actually, SCSVS is quite useful in the SDLC, right? So I'm gonna show you, I'll try to show you how it can be used on each step of SDLC. So let's start with the first one, analysis and the requirements. The first similarity is very important. It's called threat modeling. And actually, you should perform threat modeling to identify potential security threats and try to find a solution for that during the analysis, not even touching the code yet, for every kind of application, even smallest one. This threat modeling can take 1 hour, 2 hours. That's perfectly fine if your application is small. It takes sometimes more if it's huge, right? But this is very similar to all kind of applications. Do threat modeling, and that's why we have created some security requirements in our standard. And all these boxes, the gray boxes that you see, are are actually the security requirements from SCSVS. Let's go to the differences. Well, the first difference is about the sensitive data. Well, how can we protect the sensitive data in web applications? That's quite easy. We keep it in the database that is protected, and nobody can actually access the database directly. Everything is done through the web application. So the data, the passwords, user, PI rate, or any other stuff, credit cards are kept in the database and cannot be touched directly by anyone. And on the other side, you actually cannot have any kind of protected database in public blockchains because everything is public, right? So all data that you keep in your smart contracts, in your database of smart contracts, is public. So you must remember not to store any sensitive data in the blockchain. You must keep it outside the blockchain. Another difference, randomness. This is trivial to get randomness in web applications. It's a matter of one function call. In case of decentralized applications, it's not that easy because you have to get a random number which is the same on each computer in the network, on the decentralized computer. So no local parameters can be taken into account, right? And the trivial way to achieve randomness in a blockchain is to seed some algorithm with some data from the network itself, like from, I don't know, block number or any other number in the available in blockchain. And that was the case of some lotteries built on EOS or Ethereum that were hacked because the creators trivially seed their pseudo-random number generators with some publicly accessible data. So you should not do that, right? The easiest way, I would say, to get some kind of random number in blockchain is to they appeared when the blockchain appeared, and they actually can have they can manipulate business logic of our smart contracts if we do not build them correctly. And if you want to know more about this stuff, you can check out my article about the decentralized about the new threat from miners. And to mitigate the risk, you should make sure that the logic of the business logic in your smart contract corresponds to the documentation, and there are business limits that cannot be manipulated even by someone like miner who knows what are the transactions waiting in the pool, right? So let's move on to the second phase, the design. Similarities, yes, of course. Least privilege rule. You should keep in mind that everything you code, you have in your smart contract should be, you should make sure that it's really necessary to have it. Like anyone, the owner of the contract, the participants that use your contract should be able to do only these functionalities that they have to do, and nothing more. That's the least privilege rule, right? And also the access control. You should keep it as simple as possible. And even in the decentralized world like blockchain, you you should keep the access control list on one smart contract, trusted smart contract. So keep it centralized in the decentralized world. And the differences are, the difference with loops is quite tricky. The loops that end with a denial of service, which makes your program or web application or decentralized application useless because it just stops working. Well, in case of web applications, these are infinite loops, right? If you have infinite loop in your program, it will hang, right? But that is quite easy to find in the code. Infinite loops, like if you see while true, that might be infinite loop, so check this out. But in case of decentralized applications, there are loops that are not infinite by design, but may cause the denial of service in your smart contract, and they are called unbound loops. These are the loops that have not specified the exact number of iterations. And here's an example of that, the governmental smart contract, where the contract had to iterate over an array in which all participants that called transaction to this contract were stored. So any new participant, the array gets bigger. And one day, the array got so big that the Ethereum virtual machine was not able to iterate over all its elements in one transaction. So it just stopped working. Nobody could call it. And that's the case of 1,100 Ethereums frozen, which means that they are there, like you can take them, but on the other hand, you cannot, because you cannot execute any function that would withdraw these ethers. So you should make sure that you do not have unbound loops in your code. You should use some kind of different structures. And also, it's a good way, it's a good tip to decrease the risk in your applications. And in case of decentralized applications and smart contracts, the risks gets bigger when more cryptocurrency or tokens are on the smart contract. So to decrease the risk, you should simply keep as low cryptocurrencies and tokens in your smart contract as possible, just as much as it's required to operate. Okay, stage 3, implementation. Well, of course, we have great tools for both web applications and decentralized applications. I mean, IDEs, which are used, I'm sure those who create smart contracts use one of these. Maybe you know some new, so tell me. And these IDEs perform some basic security checks, and that's cool because the low-hanging fruits are easily detected by these tools. But we still make bugs. Some of them are quite tricky and cannot be found by simple checks and IDEs. So one of them are the arithmetic bugs. They are not that common in web applications, maybe in implementation of servers or somewhere on the C level, right? But not web applications themselves. In case of decentralized applications, they are quite common, actually, and they are sometimes very tricky. Let's have an example of multiple ERC20 contracts. The ERC20 contracts are used for tokens, the most common contract for managing a token. And there was a security vulnerability in some of them, which allowed to transfer decillion, I had to write it, check it out, this huge number, decillions of tokens, like it's 10 to the power of 60, just because there was a so-called batch overflow. It's not that easy overflow, it's batch overflow where more requirements have to be met. And well, in the real world, you can think of like going to the mint, and I'm sure that you understand this scenario if you've seen the first and the second season of La Casa de Papel. It's exactly the same. You just go there to this contract, get the zillion of new tokens, and go out and take these tokens with you. So, well, first you should remember to use some libraries that will check whether you have overflows or underflows. And a good example of that is SafeMath library, which you can use. And also you should make sure that you take into account the extreme values. So always think of the maximums, minimums for all your variables. And also non-strict inequality should be used instead of simple equality, because that might be sometimes tricky, especially when the float comes to the Ethereum, right? Because it's coming, or it's already there. I'm not sure, but I know it was coming. Okay, other thing, I'm sure that you all know recursive calls, and it's called reentrancy, right? Recursive calls in web applications, again, are quite easy to find because the function calls itself, or other function calls this function, and this function calls back the other function, and that we have recursive calls, right? In case of decentralized applications, it's not that easy. Again, sorry. Because sometimes a function can be called by other contract that you do not control. And if you don't make sure that your function cannot be called twice, somebody can do it, right? And that was the case of the, I guess, the most known hack in Ethereum world, the DAO hack, where about, well, for today, $1 billion were stolen, where a simple reentrancy attack was performed. So somebody didn't make sure that the withdraw function can be called many times during one transaction execution. So you should make sure that you're not vulnerable to reentrancy attack simply by blocking recursive calls from other contracts. And you should also make sure that you check the result of low-level functions, like, for example, send function. And if you don't have to use them, don't use them. Use transfer function instead. Okay, testing. Testing is quite easy in the terms of SCSVS, because there exist a lot of great tools, again, that perform some automated scans and security tests. And here you have a list, and what we basically say in SCSVS is to use them, use these tools, go through all these tools to find potential low-hanging fruits in your smart contracts. So the other thing, during development, you should make sure that you cover all functions in your smart contract with test cases. So this is like similarity with web applications. You write some new functionality, cover it with tests, like unit tests, then maybe integration tests. And if you are lucky, you are allowed also to write acceptance tests, right? But you should not forget about manual security testing, because it's not easy to find all security vulnerabilities automatically, and also it's not easy to think of every possible attack scenario during when you write your unit tests. So you should also perform, like I said at the beginning, threat modeling to find out these scenarios and then write tests for that, or simply check it manually. Because sometimes it's, especially for business logic errors, they are not easily, actually they cannot be, most of them cannot be found automatically with some automated scans. So you should understand the process that you implement and then think of potential attack vectors and then just check whether the attack vector is possible. So the test scenario ends with success or not. So number 5, deployment. In case of web applications, it's quite easy. Well, maybe that's not the good word, but it's easier because you just have to set up all things, integrations, you deploy the your application, and it's done once, right? You deploy it once, and then it's fine, it's working, right? In case of decentralized applications and smart contracts, it's there is a one catch right here, because you also set up the environment, set up the configurations and integrations with other contracts, but the difference is that the deployment logic is kept in the smart contract. In web applications, you have scripts that deploy your application, and you keep them somewhere else, not in the application. In case of smart contracts, the initialization phase, so-called deployment, is in the business logic of this smart contract. So what if you can call the initialization function again? So what if you can reinitialize the contract? And that was the case of the parity wallet, where one contract was used as a library and was used by many other contracts and was not initialized. So somebody was able to initialize it and take over it. And that was the story. Somebody, as he says, by mistake, but maybe you know more about that, initialized it and then by mistake self-destructed it. So like killed the library. So nobody else could, no other contracts that were using this library could execute their functions. So that was the second story where ethers were frozen, but here was much more, like 500,000 ethers were frozen. So how to avoid this? Make sure that all your storage variables are initialized and that you don't allow to call the initialization function twice. And of course, the self-destruct function is quite in your application, and somebody tells you that, or you get the you react. Well, in case of applications, if it's critical or it's happening now, you can just take it for some time and say sorry to your customers. But, you know, it's down. Owner can change like just like that. There are some but this process should be prepared to be attacked, and you should know what to do then. It can be completely different process, but you must keep in mind that you have to know how to react. Okay, so SCSVS is something like what fills the gap for ASVS in the decentralized world, and that was our idea. That was our main objective, to create something like ASVS for smart contracts. So I think that SCSVS meets the needs of technical stuff like developers and also business people like C-level or product owners who wants to know whether we are secure. It allows you to check the percentage coverage of security requirements. So if you want to develop secure smart contracts, or you want to perform security audit even by yourself for smart contracts, you should go for SCSVS. And last but not least, Paweł and I, we are also working on some trainings about security of smart contracts. And if you are interested in the topic, or if you have comments, or if you have any questions and are not interested in the security trainings, please go to this form, it's Google form, and sign up. You can leave your details like email, and this email will be used only for details about the training or to answer your questions. We are not spamming. Yeah, and I guess that's it. So.